The RZ gate is a quantum gate that performs a rotation around the z-axis of the Bloch sphere by a certain angle, which is usually denoted by the Greek letter phi. It is one of the elementary gates in quantum computing and can be used to manipulate the phase of a qubit state. The RZ gate can be generated using the poly-Z matrix, which is also known as the Z gate, as a generator. Specifically, the RZ gate can be written as e to the power of negative I phi over 2 times z, where exp denotes the matrix exponential function and z is the poly-Z matrix. This means that applying the RZ gate to a qubit state is equivalent to rotating the state around the z-axis by an angle of phi over 2. In quantum circuits, the RZ gate is usually represented by a box with the symbol RZ. The angle phi specifies the rotation angle around the z-axis, which can be controlled by a parameter or a classical register. To perform a rotation around the z-axis using the RZ gate, you simply apply the gate to the qubit state you want to rotate. The amount of rotation is determined by the angle phi, which can be set to any value between 0 and 2 pi. For example, if you want to rotate a qubit state by an angle of pi over 4 around the z-axis, you would apply the RZ gate with phi equals pi over 4. The resulting state would be a superposition of the original state and its z-axis rotated counterpart. The global phase factor of the RZ gate, which is given by the expression the complex exponential of negative I times half of theta, is a common factor that appears in all possible quantum states that can be transformed by the gate. This factor does not have any physical meaning, as it only affects the overall phase of the state and not its probabilities or other observables. Moreover, in most quantum computing applications, the phase factor is irrelevant and can be disregarded without affecting the outcome of the computation. This is because quantum operations and measurements are typically sensitive only to relative phases between different states, rather than their absolute phases. Therefore, for simplicity and convenience, the global phase factor of the RZ gate can be omitted in many cases, and the gate can be represented simply as a rotation around the z-axis by an angle of theta over 2. This simplification makes the gate easier to use and analyze, without sacrificing any essential physical information or functionality. The T gate is a quantum gate that rotates qubits by a small angle of 45 degrees around the z-axis. In other words, it applies a phase shift of the exponential of I pi over 4 to the qubit state. The T gate is often used in quantum circuits for creating superpositions and performing quantum phase estimation. The S gate, also known as the phase gate, is another quantum gate that applies a phase shift of the exponential of I pi over 2 to the qubit state, rotating it around the z-axis by 90 degrees. The S gate is commonly used in quantum circuits for implementing quantum algorithms, such as the quantum Fourier transform. The Z gate is a quantum gate that applies a phase shift of the exponential of I pi to the qubit state, which is equivalent to a rotation of 180 degrees around the z-axis. The Z gate is frequently used in quantum circuits for correcting errors and implementing quantum algorithms.